All right, today we're going to talk about a truly incredible mind, Murray Gell-Mann. He was the physicist who looked at this, just complete mess in the subatomic world and somehow found a beautiful hidden pattern. And in the process, he ended up naming the very things that make up our reality.
So here's how we're going to break it down. We'll start with him as a kid, this boy in the universe. Then we'll get into how he tamed that particle zoo. We'll cover his big idea, 3 quarks for Mustermark, what happened after he won the Nobel Prize, and finally, what kind of legacy he left behind.
Okay, so let's set the scene. We're starting in New York City. This is where we meet Murray Gell-Mann as a kid. And he wasn't like other boys. He was pretty quiet, kind of solitary, and his entire universe wasn't in playing games, but in things like encyclopedias, languages, and just the patterns he saw in nature. He was one of those kids. From a super young age, he wasn't just asking what, he was always asking why. He was correcting his teachers. He even taught himself physics when he was just 10 years old. For him, the whole world was this giant puzzle, and it didn't matter if he was looking at a bird flying or studying the grammar of an ancient language like Sanskrit, he was always searching for the hidden rules underneath it all. And his academic journey, it was an absolute sprint. Just look at this. He graduates high school and starts at Yale at 15. 15! By 18, he's starting his PhD at MIT and has got it by the time he's 21. This isn't just about being a genius. It tells you something about his personality. This was a mind that was just fundamentally impatient with how slow the rest of the world learned. So you've got this brilliant, impatient mind. What happens when he steps into the professional world? Well, he enters a field that was frankly a complete disaster. We're talking about the 1950s, and particle physics was just this chaotic mess of new particles being discovered all the time. They literally called it the particle zoo. And that's exactly what it was like. Every single time physicists smashed atoms together, boom, some new, totally unexpected particle would pop out. And each one had its own weird mass, its own spin, this baffling behavior, and absolutely nothing seemed to connect them. There was no map, no rhyme or reason, just chaos. So the big question on everyone's mind was, how could anyone make sense of this? Was it all just random noise, or was there some hidden order, just waiting to be discovered? And you can imagine, for a guy like Gell-Mann, who lived for finding patterns, this chaos was like the ultimate, irresistible challenge. And he went at it so methodically. Okay, step 1. He spots this weird thing, an anomaly. He comes up with a new property, and he calls it strangeness, basically to explain why some of these particles were living way longer than they were supposed to. Then, step 2. He organizes all the data. He creates this amazing classification system. Think of it like a periodic table, but for particles, and he calls it the eightfold way. And as he's looking at his own chart, he sees it. There's a gap. The pattern itself was screaming that there had to be a missing piece, a particle that nobody had ever seen before. And then, in 1964, it actually happened. The omega minus particle, the one he predicted, was discovered at Brookhaven National Lab, and it had exactly the properties he said it would. This was the smoking gun. It proved that his eightfold way wasn't just some clever little pattern he'd dreamed up. No, this was a map to how reality actually worked. But even with this huge success, Gell-Mann just wasn't satisfied. For him, organizing the particles, that wasn't enough. He had to know, what were they made of? And this pushed him towards his biggest idea yet, an idea that he'd give this totally whimsical name, 3 quarks for Mustermark. Because that's what his eightfold way was telling him, right? The patterns were just too elegant, too perfect. That kind of symmetry was a huge clue that particles we thought were fundamental, like protons and neutrons, well, they probably weren't fundamental at all. They had to be made of something even smaller. This was a huge, radical leap in thinking. For decades, everyone just assumed that protons and neutrons were it. They were the final, indivisible wall of matter. And here comes Gell-Mann saying, nope, I think we can break through that wall, and I think we're going to find something even more fundamental hiding inside. So he proposes these 3 basic building blocks. And where does he get the name? From a really obscure line in a James Joyce novel, of all places. That's just so Gell-Mann, right? This mix of super high-level physics with this kind of playful, nerdy love for language. So he called them quarks. And the most wild, most radical thing about them was this idea that they had fractional electric charges. Look, for all of physics up to that point, electric charge always came in whole numbers, always. What he was suggesting was like saying you could find, 2/3 of a dollar.
It just didn't make sense. It seemed to break one of the most basic rules of nature.
So you can imagine people were not buying it at first. The skepticism was intense. A lot of physicists thought quarks were just a mathematical trick, a cute little accounting tool, but not real. And here's the thing, you could never see a quark on its own, so that made it even harder to prove. To be fair, even Gell-Mann himself was a bit cautious about it, often calling them just useful mathematical ideas.
But despite all that debate, the model just worked too well to be ignored. Its power was undeniable. And that, of course, led to the biggest prize in science, and for Gell-Mann, a whole new world of questions to explore. And there it is, 1969. Murray Gell-Mann gets the Nobel Prize in Physics, and it was for exactly this, for bringing order to that chaotic subatomic world. It was this huge validation for a decade of his work that basically rewrote the entire language of physics.
So what do you do next when you've just solved one of the biggest puzzles in physics? Well, for a mind like Gell-Mann's, the Nobel Prize wasn't the finish line. It was just a checkpoint. He was not the kind of guy to just sit back and enjoy the praise when he knew there were so many other patterns in the universe just waiting to be figured out. So he made this amazing pivot. He turned his attention away from the infinitely small world of particles to the immensely complex world around us. He started asking how order pops up in huge systems like economies or languages or entire ecosystems. He realized it was the same fundamental question he'd been asking all along. How do simple rules create all this amazing complexity? And this new passion led him to co-found the Santa Fe Institute. It was this incredible new kind of research hub designed to study the very patterns that connect everything. I mean, everything, from how birds flock together to why civilizations rise and fall. His big goal was to build bridges between all these different fields, physics, biology, economics, that almost never talk to each other. So, as we look at the final chapter of his life, we can see that his real impact wasn't just a list of discoveries. It was really a whole new way of thinking about the universe. And through it all, he was guided by this one core belief. He believed that theories that were beautiful and elegant, the ones with symmetry and simplicity, were just more likely to be true. To him, beauty wasn't just nice to look at, it was a clue. It was a signal that you were on the right track to finding the truth. So when you boil it all down, his legacy is incredible. It's not just the hard physics he built, which is the foundation of the standard model we still use today. It's also this really profound idea that the search for knowledge is really just a search for elegant patterns. Sure, he gave us new words like quark and strangeness, but what's more important is that he gave us a completely new way to see the universe. In the end, he showed us the invisible architecture holding matter together. And he left us with this really inspiring question to think about. What other beautiful truths, what other hidden patterns are out there right now, hiding in plain sight, just waiting for a mind curious enough to go looking for them?